record this, take a snapshot of it, and just a second. Why did that not work? There we go. All right, just go through them. One, starting with 1.
Yes, please.
What's 1? It's the derivative.
The derivative of 1.
Well,
wouldn't that be
what's y prime?
0?
What's the derivative? Do it term by term. What's the derivative of minus 10x?
Would that just be x?
Just be minus 10.
Or minus 10, never mind, because of the power property. Okay.
Right, just power rule. In other words, what you really have is minus 10x to the 1. Start with the exponent, multiply it by the coefficient, you get minus 10, and then you end up with x to the 0. Well, anything to the 0 power is 1. So it really is a perfect application of the power rule. And what's the derivative of 3 cosine x?
Would it just be 3?
No, it's negative sine x. In other words, the derivative of cosine x is minus sine.
I need to go over that then.
Let's do it. I have a perfect way to go over that. I can show you how to memorize it. On the left is the function, on the right is the derivative. Now, some of these are tougher to remember, but there's a method to these, which I'm about to explain to you. Up, 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 up. Sometimes I can't understand why Windows designs it the way it does. Those are the derivatives of your 6 trig functions. Now, notice something. You know what a cofunction is, right? You know what the cofunction to sine is?
Cosine x.
Just stick a co in front of it. That's what cofunction means. So the cofunction to tangent is cotangent. The cofunction to secant is cosecant. Notice which ones are positive
the ones like on
the functions, not the cofunctions. And
okay.
Which ones are negative? The cofunction of sine is negative. In other words, cosine is the cofunction of sine. Also, the cosecant is negative and the cotangent is negative. So anything that starts with a co is negative. Not only that, but this part here is not only, that's also going to be the cofunction of the first one. And this part here are each the cofunctions for the secant. Notice above it. See what I've circled at the bottom right? Notice that above it are the 2 cofunctions of those 2. And when I do the cotangent, I get minus cosecant squared, which is the cofunction to secant squared. So I'm not sure if I'm making myself understood here, but you only have to memorize 3 of these. The ones that I've check marked on the left.
Okay.
In other words, if you memorize what the derivative of sine is, and tangent, and secant, you can figure out all the others. In other words, if you know that, let's take tangent. If you know the derivative of tangent is secant squared, well then you know that the derivative of its cofunction, which is cotangent, has to be, first of all, negative, and then it's the cofunction of secant squared, so it's cosecant squared. You understand,
Okay.
you understand what I'm saying?
Yes.
But you do have to memorize these first 3. And it's a little confusing because the second one they always have you memorize is the cosine of x being negative sine x. And that's really an improper way to learn these. The best way to learn these is to learn the first 3 that I've check marked on the left, because you do not have to memorize the other 3. You just have to figure them out based on the fact that they are the cofunction and their derivative is the cofunction of the other's derivative.
Okay.
Okay? So, the derivative of cosine, therefore, must be negative, for one thing, and its sine, which happens to be the cofunction of cosine. That's not why it's the answer. It's the answer because the derivative of sine is cosine. So the derivative of cosine has to be,
Negative sine.
well, has to be the negative, yes, it has to be the negative of the cofunction of the other one. So yeah, negative sine. And the 3 just goes along for the ride. In other words,
To a negative 3 sine.
negative 3 sine. All right, let's look at this one. What's a better way to write 3 over x? Because having your variable in the denominator is not very helpful. What we want is our variable in the numerator such that we can use the power rule. So what's a better way to write this function? Instead of 3 over x, what should I write? About 3x to the minus 1.
Okay.
Now you see why that makes it easier, because now you can apply the power rule. So what's y prime?
Negative 3.
Subtract 1 from the exponent.
That'll be to a negative 2.
That's the derivative of 3x to the minus 1. Is negative 3x to the minus 2. And what's the derivative of 5 sine?
That would be 5 cosine x.
Yep. Okay, let's look at number 3. What rules do we have to apply on number 3 of your derivative rules?
Power property for x squared.
Okay, so we got to use the power rule, but we also have the product. In other words, we've got x squared multiplying cosine of x.
Instead of just adding.
So we need the product rule, exactly. In the first two problems we were just adding, so we didn't need a product rule. But in this one we do. So if, first of all, over here on the right, if y equals two functions multiplied together, then y prime equals u v prime plus u prime v. You can do those in either order. So here we have two functions multiplied together, x squared times cosine x. So let's just go through it. What's y prime?
Y prime. Would that just be UV?
Well, what's u and what's v? U is x squared. In other words, our function was x squared cosine x, which means u is x squared and v is cosine x.
V is cosine x.
Okay.
So x squared cosine x plus x squared cosine x.
There's a negative sign in front of that because remember the derivative of cosine is negative sine.
Okay.
Plus, what's the rest of it? What's u prime v?
X squared
No.
and negative sine x.
Hold on. U is x squared. What's u prime?
Say that one more time, please.
U is x squared. So what's u prime?
2x to the 2x.
2x. And then v is still cosine x. So
Okay.
that's the answer. And you have to use the product rule.
Gotcha.
Okay. Number 4. Here, again, the things that don't serve you well in calculus are radical signs and variables in the denominator. So let's get rid of the radical sign. Rewrite this number 4. How should number 4 read so that we can do it easily? Y equals what?
X to the 1/2.
Right. In other words, use fractional exponents. So all I'm doing is rewriting the function to make it easier to deal with.
Okay.
Now use the product rule on that part.
So UV plus UV prime.
Right. And I would make it a habit to always do it the same way, even though they're being added, so you can do the associative property, so you can do it in either order. In other words, you could also do u prime v plus uv prime. Just do the opposite, okay, in each case. So, however you like to start it and stick with that order. So if you're going to do uv prime, let's do that. What's uv prime?
UV prime.
That's u. That's v.
1/2 x to the negative.
So you're doing u prime v. It's okay. Don't have any problem with that. But I think you'll memorize it better if you always do it the same order. Either always do u prime v or uv prime as your first step. Don't mix it up.
Okay.
So I don't care which order you go with, but try to stick with it.
Would it be secant x squared?
No, start with the x to the 1/2, but either take, in other words, remember y prime is uv prime plus u prime v But you could also do that u prime v plus uv prime. So you can do it in either order as your first step.
Okay. I'll just keep it simple and I'll just
I would
do...
always do the first order. In other words,
Okay, so
always
x
start
to the
the
1/2.
answer with u. So x to the 1/2, that's u. Now, what's the derivative of secant x? That's one of the three you need to memorize.
Secant x squared?
Secant tangent.
Secant tangent, okay.
Secant x tangent x. Okay, so that's the uv prime. Now, what's the u prime v?
Now, it's 1/2 x to the negative 1/2.
Good.
And secant x.
Okay. And then what's the derivative of 3?
Would it be 3?
0. The derivative of all numbers is 0. And a way to look at that is pretend that it's y equal 3 times x to the 0 power. No?
Okay.
Hold on. You can't look at it that way. It just occurred to me. Wow, I never realized that. You can't look at it that way. Because the first thing I would do would start with the exponent, multiply, and I'd get 0 times x to the minus 1. So you can't look at it that way. Just memorize that the derivatives of all numbers is 0. Yeah, and that's why you can look at it that way. What am I thinking? It's 3x to the 0, okay? So the first step is you start with the exponent, multiply it, you get 0. You get 0 times x to the minus 1, but since 0 times anything is 0, then the answer is 0. So it is okay to think of it as a power rule.
Okay.
Okay, so our final answer to 4 is that. In other words, the derivative of 4 is just the derivative of that. We don't have to consider the number.
Say that one more time, please.
In other words, we immediately discard this plus 3 when we see the problem.
Yes, because it gets canceled out.
Yeah, so that could not be there, and the derivative is going to be the same.
Okay.
Okay. So number 5. Let's do it piece by piece.
This looks complicated somewhat.
Not as bad as it might seem. Here, let's write it over here on the right. We'll do it piece by piece. And that's the way we're going to give our answer. First of all, what's the derivative of that? What's the derivative of secant?
Cosecant x times cotangent x.
Very good, but it's got to be negative.
Okay, negative.
Cosecant x, cotangent x. Because you remember that the derivative of secant was secant tangent. So these two are the cofunctions of secant tangent. Okay, so that's the first term. Second term is 4x to the 1/2. That's not hard to differentiate. What's the derivative of that?
That would be 2x to the negative 1/2.
And finally, the third term is 7 over e to the x. Well, again, let's put that with the variable in the numerator. How would I write e to the x in the denominator as a numerator? 7e to the minus x. Remember,
Okay.
that variable's in the denominator. You can move it to the numerator and make it a negative variable. Now, You cannot use the power rule on this. We wanted to move it to the numerator, but we still can't use the power rule. You cannot use the power rule when your variable is in the exponent. This is not minus 7x times e to the minus x minus 1. The one thing you have to remember is that if y equals e to the x, what does y prime equal? It's the only function in the universe that is like this. Its derivative is the same as the function.
Okay, that's weird.
It is weird. But the derivative of e to the minus x, you have to apply the chain rule. So when you take the derivative of the outside, you get 7e to the minus x, but then you have to multiply that by the derivative of the inside, and that's the inside. What's the derivative of minus x?
Minus x. That would be 7.
No, just negative 1. In other words, the derivative of minus x. Here.
Okay, because it's invisible exponent to the top right.
Right, let's go over here. As long as we remember the derivative of e to the x is e to the x, okay?
Okay.
So if I have a function that's e to the minus x, then the derivative, I got to apply the chain rule. The derivative of the outside is the same, e to the minus x, but times the derivative of the inside, which is minus 1. So it puts the minus in front of it. So the derivative of e to the minus x is minus e to the minus x. Just like, here, let's do another easy example. If I had e to the 3x, what's the derivative of that going to be?
E to the 3x.
Almost. That's the derivative of the outside. What's the derivative of the inside?
Inside. So
that's the inside. What's the derivative of that?
3.
That's my answer.
Okay.
Okay. So, to our problem that looked complicated, it's not that complicated at all. Whenever you can do derivatives piece by piece, in other words, when I don't have to worry about a product rule or quotient rule or anything like that, notice that I could have used the quotient rule on that. But what's easier, using the quotient rule or turning it into e to the minus x? Turning it into e to the minus x is a heck of a lot easier to differentiate
a whole different rule
than using the quotient rule. The quotient rule is a bitch. Okay, so the next one. Let's start with that part right there. Use the product rule on it.
Okay. So u prime v.
Hold on. It's uv prime. Always do it the same way.
Prime. Okay, uv prime and then u prime v.
Right. So what's uv prime?
Okay, so u would be x squared cotangent x.
No. That's u. V
cotangent
is cotangent x, so we need v prime next to it.
Then what's the negative 1 over x squared?
Well, we're getting to that. We're doing these one at a time. In other words, whenever you're differentiating terms that are separated by pluses and minuses, then you can do them one piece at a time. They're no more complicated. Then you can have 10 terms. It wouldn't make it any more complicated than one term.
Okay.
Okay? But at the moment, we're dealing with this first term, which is x squared cotangent x. That requires the product rule.
Would that be negative cosecant squared x?
Almost. It's negative. When I was doing tangent, What was the derivative of tangent? Secant squared.
Secant squared x.
So what's the derivative of cotangent?
Cosecant squared?
Yes, with a negative in front of it. And I can move that negative to there. Okay. Now, that's just the first half of the product rule. What's the rest of it? In other words, you just did u v prime. Now do u prime v.
2x to the negative, or no, just 2x.
Okay. Times. That you just did u prime. I need the v.
And that'll just be cotangent x.
You got it. You got the product rule?
Yes, now I got it.
Good. Now let's get to the second term. Again, how should I write that term?
We should get it out of the...
Okay, so tell me how to write 1 over x squared in a calculus way.
1 to the x negative 2.
It's not 1 to the x, it's x to the negative.
X to the negative 2, because the 1 doesn't count. Okay.
Right. Now use the power rule on that.
So that would be negative 2 x.
Keep going.
With the minus 3.
Okay. There's your answer. See, it wasn't that hard. It's all we had to do is make sure that we see we're dealing with two terms here that are being subtracted. Now, I didn't quite get the answer right because that was being subtracted. So it was a negative x to the minus 2. So this is actually a positive right there. See why? In other words, if you take the derivative of that, you get minus 2 times a minus, so it becomes positive.
Yeah, so that'd be positive 2.
Well, it'd be plus 2x to the minus 3rd is the proper answer to number 6. This is the answer to number 6.
Okay.
Okay. Now, Taylor, I got to run. I got a 4:30 today. So
okay, sounds good. Thank you.
Talk to you next time.
Okay, sounds good. Have a good night. Bye.
You too.